Okay, 1-6, compound inequalities. If you don't know what compound means, well, a lot of you guys should know what a compound word is. So book, store. There's two words, book and store. Put them together, bookstore. Exactly. Okay, let's look at this example here. Hannah has some blue paint. She wants to lighten the shade, so she mixes 1 cup of white paint. It's still too dark, though, so she keeps mixing in 1 cup of white paint at a time. After adding 4 cups, though, she then notices that it's too light. So let's explain in words how much paint Hannah should have added initially to get the shade that she wanted. So notice how 1 cup was too dark, but then when she got more than 4 cups, it got too light. So that means it needs to be between 1 and 4 cups in order to get the paint that she wants to get, okay? So here's the ordeal, okay? If we're gonna use one or more inequality, well, we know that C has to be greater than 1, but it has to be less than 4. Or if I wanna use this idea, C has to be between 1 and 4. So what I could say that C could be greater than 1, but it can also be less than 4. This right here is what's known as a compound inequality. And usually what we use compound inequalities for is when we're talking about in between. So for example, 2 is in between 1 and 4. 3 is in between 1 and 4. 3.5 is between 1 and 4. Because that shows that we want that number to be between it. So when we have something in between, that's known as a compound inequality. So let's look at this right here. How can we use inequalities to describe the sets of numbers graphed below? Well, notice how we'll call these x, okay, essentially. Notice how -3 and its number is less than that. So I can say x is less than or equal to -3 because there's a hole there that fills it up, or it's got to be greater than 2, okay? Since it's not there's no in between, I'm not going to put an in between. So there you go, okay? What about this one, though? We know that these numbers are between -4 and 1. So notice how it's greater than -4, less than 1. There you go. That explains it. Let's do these real quick, okay? We know that this is what we're working with, the x's, okay? So I can say x has to be bigger than -2, but it's got to be smaller than 6. Voila, that's it. If it's in between, you write one big inequality sentence with 2 of them. But if they're separate, broken, then you write 2 separate ones. For example, I'll draw one right here. Let's say 6 and then 11. Let's say I shade this way, and let's say I shade this way. Well, x has to be smaller than 6, or I have to say x is gonna be greater than 11, essentially, okay? It can't be between it, so I'm not gonna write it like this, okay? So keep that in mind. What if you're given beep, bop, boop, bop, like this? Well, just solve them separately. Simple, okay? We can say x has to be less than 4 and also be less than -2. If I were to draw both of these lines, well, I know that -2 is still less than 4. So I could just say that x has to be less than 4. If you write both, that's fine, but just show that it's either or, okay? Let's work with this one here. Let's try to get this by itself, okay? My hint is this. What you want to do, and I'm actually going to pull out a separate sheet of paper, okay? My hint, if you're given 2 inequalities, do them separately. Your goal is to get x by itself separately, okay? So I'm going to draw a line to split the inequalities, and the first inequality I'm going to write is -3x plus 2 greater than -7, and then the other one, 2 times x minus 2, 2 times x minus 2, okay, beep, bop, boop, okay, is going to be greater than or equal to 6. Okay, let's get x by itself. Let's do them separately. I'm going to move the 2 over. Okay, so -3x greater than -9. Divide by -3, we have to fill up the inequality. It's 3. Okay, same thing here. Distribute the 2, 2x minus 4 greater than or equal to 6. Add the 4. Okay, divide by a 2, x has to be greater than 5. If I were to draw a number line real quick, let's draw the number line real quick. Okay, here's 3, here's 5. X has to be smaller than 3, x has to be bigger than 5. There's nothing in between, so guess what? Those are your answers. It's either x less than 3 or x is less than 5, essentially. Okay? What about this though? What if there is an x in between two numbers? Well, you want to draw a line to, well, I'm actually not going to draw the line like this. You're going to write two different inequalities, and you're going to do it separately. So notice how the 7x plus 9 carries to both of them, to both the numbers on the outside. And your goal is to get x by itself for both of them, okay? So let's work out this one right here. Notice how they're separated already? So all you got to do is just write them both separately. Simple as that, okay? So here we go. -2. I got room here. Yep. So -2, parentheses x plus 1, less than 4. I'm going to draw a line, okay? And then 4x plus 1 is going to be greater than, or sorry, less than or equal to -3. Just get x by itself. Distribute the -2. -2x minus 2 less than 4. Add the 2. Divide by -2. X has to be greater than 3, and it's negative. Okay, let's look at the other one here. I'm going to subtract 1, 4x less than or equal to -4. Divide by 4. I'm not dividing by a negative, so I don't flip the inequality. Okay, x has to be less than -1. So here's -1. Here's 3. I know it's got to be bigger than -3, sorry, -3, but it's got to be less than -1. And -3 is smaller than -1. So I can actually say the inequality is going to be like this. Okay, x is going to be less or greater than -3, but it's got to be less than or equal to -1. So since it's an in-between kind of thing, there you go. That's how it's written there. And -3 again is smaller than -1. That's really important. Okay. Let's look at the next example here. Oh no, a word problem. Okay. Enrique plans a diet for his dog, River. River consumes between 510 and 540 calories per day. If River eats 1.5 servings of dog food each day, how many treats can she have? So she eats 320 calories per serving, and she eats 1.5 of those servings. So if you, and remember that 1.5 is 1.5. If you want to figure out how much she eats based on her servings, just multiply 320 by 1.5. And again, you can use good old Desmos. So let's figure that out. 320 times 1.5. Voila, 480. So she eats 480 calories, but she wants to eat treats, and every treat is 15 calories, okay? The amount of calories that she's allowed to eat is between 510 and 540, okay? The thing that we're gonna compare with is 480 plus 15x, and we know it's gotta be between 510 and 540. We do it separately. So she's allowed to eat 2 and 4 treats, in between 2 and 4 treats, okay? So now let's focus on this here, okay? So now suppose instead of 15, it's 10. So this 15 is gonna change to a 10, okay? Let's write out this, 510, okay? 480 plus 10x, and then 540. What I'm gonna do is I'm gonna do the work on the left side here, and I'm gonna separate it. So 510 plus 10x, okay? So 510 plus 10x, let's write that a little bit better. Okay, it's got to be less than or equal to, wow, I did not do that right. So 510 is the smallest number. Less than or equal to 480, there we go. Okay, get x by itself, move the 480 over here. 30 less than or equal to 10x. When I divide by 30, it's going to be 3. So x is allowed to be greater than 3, but 480 plus 10x has to be smaller than 540. Okay, move that over again. You get 30. Okay, so, oh, not 30, but 60. Divide that by 10. She's allowed to eat in between 3 and 6 treats. So that means x has to be between 3 treats and then 6 treats. That's her limit. So no less than 3, no more than 6 to equal her calorie intake. She can't eat any more than 6, and she shouldn't eat any less than 3. Okay, I think that's the last problem of this lesson. Yes, it is. Straightforward. If you're given more than one, you want to separate them, okay? And if I go back to this, Notice how I drew a line in between to separate the two inequalities. And your goal is still to get x by itself for both of them. Okay, that should cover that ordeal. Okay, good luck. 2 more lessons to go for Tuesday.